All right, so this is, again, a 2018 question, number 3, however, not in the notebook. It's from an old practice exam, well, not too old, the 2018 practice exam. So again, print it out or just use it from the sheet that I sent you. The function g of x is defined on this closed interval, so I want to highlight this is g of x, and it consists of 2 line segments and a semicircle. And now f of x is over here, so we are going to have to take our time and just keep them straight. Are we talking about g? Are we talking about f? So be super careful. So part A says find f of 7. So I'm going to start with f of 7. So I'm going to go to this function and just replace my x's with 7. So I have 3 times 7 plus the integral from 0 to 7 of g of t dt. So you can see that they both come into play here. Obviously, this is 21 plus I have to integrate g of t. So I have to go over to this function. I have to find the area from 0 to 7. So I'm just going to shade it in for myself so I know what I'm talking about. I need this area, so that's 0 to 6, and then I need to 7. Okay, so this section is a semicircle, so that's 1/2 pi r squared. Let's see, my radius looks like a radius of 3, so I'm going to call that 9/2 pi. And notice it's sitting under the x-axis, so I'm going to slap a negative in front of that. So that is negative 9/2 pi. This is just a nice rectangle, base of 1, height of 3, so I would say it has an area of positive 3. So I have 21. And I have a negative 9/2 pi plus a 3. So I'm going to say that's equivalent to 24 minus 9/2 pi. Now there was 2 parts in here. Now they want us to find g prime of 7, or I'm sorry, f prime of 7. So I have to go to function f. So I'm not going to do f prime of 7. I'm going to find f prime of x first. So I'm going to go to function f and I'm going to carefully derive it. So the f of x becomes f prime. The 3x becomes just 3. And then again, we'll apply that second fundamental. So I'm going to get plus g of x times 1. So I've got f prime of 7 is equal to 3 plus g of 7. And if I look at my graph, I'm going back to g. g of 7 is equivalent to 3. So I would say 3 plus 3 is equal to 6. All right, find the value of x in the closed interval at which f attains its maximum value. Justify your answer. So let's pull out some key calculus terms. First of all, they're talking about function f, so let's highlight that. And then the calculus word would be a max. So I'm going to start with a justification. Before you can find a max or a min, we always want to set f prime equal to 0. And kind of just make that chart for yourself. They usually are looking for that for one of the points. And then once f prime equals 0, I need to know if f prime changed from a positive to a negative, and I'm kind of just abbreviating there. So since they're talking about f, let's go grab f again. So f of x was equal to 3x plus the integral from 0 to x of g of t dt. And again, I want f prime, so I'm just going to simply take its derivative. So f prime of x is equal to 3 plus, apply that second fundamental, g of x times 1. And like we said, we want to set that derivative equal to 0. So 0 equals 3 plus g of x. And the only way really to solve it is to move something to the other side. So I'm going to subtract that 3. So negative 3 equals g of x. So now, when two things are equal, we're always looking to see where they intersect. And what's convenient is you happen to have a graph of g of x. All you have to do is graph y equals negative 3. So if I graph y equals negative 3, I can see that they're equal once right there. And that would be at x equaling 3. Part C. For each, evaluate these limits and then find the value or state that it does not exist. So notice it says for each. Whoopsies. So I need the limit as x approaches 0 from the left. Now notice who they wanted of g prime of x. Okay, so a lot of us get a little excited and we just look at this graph, but this is a graph of g, and they wanted of g prime. So you are now looking at the what of this graph? The slope. Good. We want to make sure we're looking at the slope. So I need the exact slope as I approach from the left of 0. Now this one's super easy because the slope is all the same because it's linear, so I literally just have to calculate the slope. So it looks like I'm going down 2 and over 4. So I'm thinking rise over run. So I'm going to call that a negative 2/4 or a negative 1/2. Now I need the slope as I approach 0 from the right. Okay, so look, these slopes are constantly changing, right? And you know that this comes to a cusp or a corner, so the overall limit does not exist. And since we can't calculate this slope because they're constantly changing, we're going to say that limit of that slope does not exist. Our last question is a nice general limit. Now, I would expect to see something that's on the practice exam, especially with notation that they're looking for. So they want the limit as x approaches -2. So don't forget your first step, and this should be a lot of work, is always that direct substitution step. So you're just going to go in and replace everything with that -2. I'm going to do the math up here. I get -6 plus 6 minus 1. This becomes e to the 0. E to the 0 is 1. 1 minus 1 is 0. And let's see, f of -2. So let me jot down that f function again. It's 3 times -2 plus the integral from 0 to -2 of g of t dt. So 0 to -2 would be this section. That's a 1/2 base times height. So let's see, right now I'm at -6. That's going to get me a -1. So that's a -7 plus 7. I'm going to get that 0 over 0. Now here's the catch. When we're using, obviously this is L'Hopital's rule, 0 over 0, indeterminate. When we're using that, the AP states that we have to write these separately. So I do have to write the limit as x approaches -2 from the numerator equals 0, and the limit as x approaches -2 from that denominator equals 0 as well. This is something they are looking for, and we just want to make sure we do it. We're going to state them separately. This is fine to state this way, but then we're going to have to state them separately. So now we can apply L'Hopital's rule. We can take the limit as x approaches -2, and I'm going to get f prime of x over 3e to the 3x plus 6. So I'm deriving the numerator, deriving the denominator, and then I'm just going to try it again. I'm going to substitute in that -2. So let's see, I get the limit as x approaches -2. Keep that limit in there, of f prime of -2 all over 3e to, that's going to be -6 plus 6. So that's e to the 0, which is 1. So I know my denominator is going to be 3. Now I need f prime of -2. So I'm going to go back and find that f prime. I'll do that up here. So that's going to be 3 plus g of x. So I need 3 plus g of -2. So g of -2 looks like a 1. So that's 3 plus 1 is 4. I'm getting a nice 4/3.